spaceexplr episode. We have a very special guest today on the show, and his name is Mark W. Johnston. So he is NASA Solar System Ambassador, Astronomical League Master of Outreach, Astronomy and Space Science cruise ship speaker, amateur astronomer who's been doing that for the past 50 years. I mean, there's a lot of experience and a lot of great topics that we're going to be diving in today. And make sure to get in contact with Mark and follow him on Instagram. You're going to find that link below as well. A website is called telematrix.com for more information. So Mark, big thank you again for coming over today to this episode. Appreciate it.
It's great to be here. Thank you.
Thank you. Thank you. Again, hopefully, again, everything is going smoothly because the last time we had some technological issues. So, but hey, look, life happens, right? So first of all, again, 50 years in astronomy, you know, I mean, that's very long time, you know, like I wasn't even born, like I'm only 30 and I've been involved in this for 50 years. So that's crazy. So can you talk about your personal experience? I mean, how did you get involved with it and stuck with it for 50 years?
So when I was 11 years old, my father gave me a telescope for Christmas. It was an old Tasco 60 millimeter refractor. Just had two little 0.965 eyepieces, kind of a low power and a high power. And I took it out in the backyard in the snow in Toronto, Canada. And I didn't know what I was doing. And I was just sort of pointing it at different things and went from one star to the next star. And then I saw this one particularly bright star appear over the trees. I thought, well, that's kind of interesting. So I pointed at that with my low power eyepiece, and it was shaped like a football, like a, you know, an oblong shape like that. I thought, what could that be? It clearly isn't a star. And so I only had two eyepieces. So I took that out and put the other high power eyepiece in, and I focused really carefully. And I realized I was seeing Saturn with the rings. And I had discovered Saturn at 11 years old in my backyard. And it was such a thrill to see the rings and Titan beside the rings and the little Cassini division in the rings. Even with a small telescope, you can see that. And it was just something that thrilled me, and had my parents rush out in the backyard and have a look. And it was something that stuck with me, and it got me interested, and I kept with it all throughout my whole life.
And that is amazing. I mean, we don't get a lot of people just like yourself on, you know, who, because I think for a lot of people, including myself and some of the people who are watching or listening to this episode, in a young age, everybody kind of, what do you want to be? An astronaut, a fireman, you know, a doctor or something like that. A lot of people say that.
Yeah.
And they lose it, you know. So how did you not lose that, you know, your personal passion for that? Give us some recipe.
Well, I don't know if I have a recipe. It's just something I was always interested in, and I would read about it. You know, back then, of course, you didn't have the internet, but I would get books, and I would read books on astronomy, and I would get sky charts and see how to find the constellations, and slowly learn more and more and get binoculars. And you know, I went through a succession, like we all do, of better and better telescopes throughout the years, and trying reflectors and refractors and compound designs and different things, seeing what worked for me. And you know, I had interest in planets, then I had interest in galaxies, and you know, different things, double stars for a long time. I do some double star research, in fact, right now. So I had an interest in different things throughout the years. I just sort of kept at it. And if I was on a trip, you know, fortunately with my work, I was doing a lot of international travel. And so I'd have a chance to go to, you know, Sydney, Australia, or South Africa, or, you know, Brazil, and I'd see the Southern Hemisphere, and you could see the Magellanic Clouds and things that are impossible to see from the Northern Hemisphere. And that was very exciting as well.
Got it. Okay. So can you talk about part of your personal journey? I mean, did you get involved with some sort of a community and, you know, groups? Because of course, Facebook wasn't around at that time. I mean, how did you, you know, like ignite your passion to make sure that you know, you're going with that forward? I mean, can you talk about some, you know, educational resources, maybe a few books or good books that you can give us, you know, that I think will inspire, you know, a few people who are watching?
Sure. Well, I would say as far as the community of astronomers, there are local clubs pretty much in every city you can imagine. And for me, it was the Royal Astronomical Society of Canada, which is in Toronto and, you know, throughout Canada. Originally, that was the first club that I was a member of, and got very involved with them. And I know I remember in high school taking a telescope up to the top of one of the tallest buildings in Toronto to watch a Mercury transit of the sun during the day with a science teacher. We did that, a high school teacher. So I had interest in pursuing things like that throughout the time. Turn Left at Orion was a good book. Terence Dickerson's written a lot of good books about introductory astronomy. I like him as an author. You know, I just read everything I can get my hands on essentially, and just tried to get smarter about the topic. And what's really fascinating, you know, I've been studying this topic, as I say, for decades, and yet the pace of discovery in astronomy is like exponential. And it's almost every week something new and exciting is being reported. And the frontiers of what the universe is getting bigger and bigger. I mean, when I was a kid, we had 9 planets, and there was no such thing as dark matter or dark energy or the multiverse. And those are all new things that expanded our horizons. And you know, knowing every time we learn more about the Milky Way, we realize there's more stars and it's bigger than we thought. And same thing for the galaxies around us. And it's just fascinating, all the new science that's being discovered.
Yeah, but I mean, at the same time, Luke, you lived in really great times, because we're talking about Voyager 1 and 2, you know, launch at that time. So you've seen that one probably, right? You've been
Yeah, well, in fact, I was born the month that Sputnik was launched, October '57. That was my birth month. So that was kind of space related. And you know, I was at JPL a couple of years ago when I was on the mission control, and you could see data coming in from Voyager 2. You could see the big telescope and antenna in Australia, and the little signal coming in. And you could see on the board that ship had been active for 41 years at that time, 43 years now. Yeah. So it's just amazing. You know, you think about that mission, the Voyager missions, the TRS-80 was the state of the art in computers back then. It had 4 kilobits of memory and an 8-bit processor, and just, I mean, it's hard to believe now how the technology's progressed, and yet they have an active space probe with that technology still functioning at the frontiers of our solar system.
Yeah, because we just got a signal from Voyager 1. I think that was only like a week ago or something.
It was actually Voyager 2. They had to take down some issues with the antenna in Australia had to be repaired, and took about 9 months to make the repair. When that done, they sent a ping to the spacecraft and responded right away. So it's still functioning.
That is incredible. That's great. That is incredible.
Yeah.
So again, and part of that, you've been Apollo 11. I mean, talk about that, you know? So
when I was a kid, 11 years old, I was sitting in a cottage, again in Canada, and we had an opportunity to an old black and white television set to see Neil Armstrong descend the ladder and step on the moon. And I remember stepping outside and looking up at the moon that same night and thinking, there's somebody up there right now walking on the surface. I mean, it was just incredible.
Wow. Yeah. So, I mean, during these times, because I mentioned there is just so much information going on, and we kind of live right now in this informational age. So what would you recommend then, maybe from your personal experience, when it comes to kind of consuming information? Can you give like a few resources that people can go and kind of immerse themselves into all this great information?
Wow. Well, I find that there's a lot of advantage in meeting with other people. Now, there's some challenges now with COVID, of course, which restricts what you can do. People are doing things on Zoom now more than face-to-face, but still, you know, when I came down, I moved to Arizona about 30 years ago, and in the US, and I immediately joined the clubs down here, a member of several clubs in the local area. And you always learn things about the night sky. There are a lot of resources that are free. And so somebody who's just trying to get into this for the first time, I mean, one of the first questions you get is, what telescope should I buy? And I always answer that. It's kind of like, what car should I buy? It depends on your needs and your interests and your budget and a whole lot of things. And there are great opportunities you can have that maybe once we get past this COVID situation, get back to having what are called star parties, where amateur astronomers take their telescopes out to a local park or a library or some kind of a setting, and the public's invited to come for free, and they can look through different telescopes, reflectors and refractors and compound designs and different things, and see which one kind of appeals to them and what they like the look of, and the ease of use and practicality and the weight and the complexity and the cost and so on. That's a great way for people to kind of test drive different types of telescopes to see what might work best for them. But so you can do that. There's a lot of internet resources. You know, NASA's got a fantastic site with a lot of public information stuff there. So there's ESA for Europe, and there are many other sites. You can just Google and find, you know, a rich canopy of images to look at and science information. So I just kind of absorb all that stuff. I'm a member of a number of different newsletters, and astronomical societies and get newsletters and things like that from them. And I'm following a lot of people on Instagram that, Neil deGrasse Tyson, people like that publish interesting things. So I just try to consume as much information as I can from many sources as I can.
Got it. Got it. Good, good, good. Continue to do that after 50 years plus. So that is awesome. That is awesome. It's just innovation
Yeah.
and the information. I mean, there's so much to
Yeah.
be learned still.
Yes,
Yeah.
absolutely.
So, I mean, so talking about that, let's say, because when I looked through your Instagram account, and, I'm very happy that we're connected there as well, it's called As Astro Guy. And of course, you're going to find that link with the rest of the social medias and everything in the show notes. But for somebody who's looking to get involved with astrophotography from an equipment standpoint, what would you recommend for people to when they get started?
Well, again, depends on the budget and the sort of things that you want to take photographs of. You can do, I actually started with iPhone photography, which sounds pretty primitive, but you can get for less than $10, you can get a simple bracket that holds your phone and attaches it to an eyepiece on a telescope. And you can take simple wide field pictures of things, constellations and things like asterisms like the Pleiades and things like that, and get a reasonable picture actually for almost no cost. People who have a DSLR can set up a DSLR on a tripod, and as long as you limit your exposure time, you can get from a dark side a picture of the Milky Way or of Orion or things like that. So you can do simple things there. There are tons of resources on YouTube. You can just look up astrophotography for DSLRs or for whatever. So I did that for a little while. Really my passion for the longest time was simply visual astronomy and outreach. So I've been doing a lot of public events for people for a long, long time. I go to public parks locally here and have my telescope and have flyers up, and people come look at through the eyepiece and they see galaxies and nebulas and planets and different things. So I did that for the longest time. And then fairly recently, there's been some tremendous technology advances in CMOS cameras. And there are companies like ZWO, ZWO, or QHY, and they make some fairly low cost, relatively speaking, CMOS cameras that have tremendous sensitivities. And I remember, showing people things like the Lagoon Nebula or something in my telescope, and you'd see kind of a gray smudge. Okay? Visually, in real time, it's not that impressive compared to the photograph you see on the internet. But when you take a digital camera, like a one-shot color camera, and you attach that to your eyepiece, even with a modest-sized telescope, a 5.5-inch or a 4-inch refractor, you can get a beautiful full-color image in just 30 seconds. I remember showing people the Horsehead Nebula, which is something which is almost like the Holy Grail visually. It's so hard to see unless you're really, really off in the dark area and you've got a very large aperture telescope. But from a city, it's almost, you forget it. Well, I can routinely show the Horsehead Nebula with a small telescope in full color live with a digital camera through my computer. So the technology's come a long way, and you can look into that, and it can be very rewarding.
Got it. So on that note, I'd say, because as I said, like astrophotography for some people, especially during these times where there's a lot of uncertainty, they know not sure what's going to happen in the future with their jobs or businesses, it could be a little bit pricey. Of course, like you can go as low as, let's say, of $500. You can probably put some decent equipment with that, or you can go as high as 200,000 or more.
Yeah.
So
yes, of course.
Yeah. So, but talking on that, would you recommend for people still maybe use telescope live? Remote kind of observatories instead of, buying, equipment themselves?
Yeah, you can do that. There's a lot of equipment you can buy used as well. Unfortunately, the sad reality is a lot of people buy telescopes and then for whatever reason, they never really get into the hobby, and it sits in a garage or a basement somewhere, just gathering dust for a year or two, and then they finally decide to sell it. And you often can pick it up it's been used once or twice, and it's only half the cost of what a new one would be. Yeah. So as long as you take some care with that, obviously with a telescope, it's something where you want to have some level of expertise when you evaluate a used instrument. So maybe you take someone along with you that knows more about it than you do if you're a beginner, and they can help evaluate that it's still operating properly and has all the right pieces and so on. But you can save a lot of money by buying used equipment. And there also are a number of good websites like astromart.com or cloudynights.com where they have classified sections, kind of like the eBay for astronomy, if you will. And that allows you to pick up things, and you can see how people have been rated, whether they've had a lot of transactions with positive results and so on. So you can feel a higher level of confidence that you've got a good deal. And these sites also have forums where you can ask questions and get expert astronomers to give you feedback and suggestions on how to solve the particular question you've got or answer the issues you have. So a lot of resources out there for you.
Yeah, yeah. Okay. So when it comes to using equipment, can you share what type of personal equipment are you using currently?
Okay, currently I have 3 telescopes. I have a solar hydrogen alpha telescope. This is made by a company called Lunt here in Arizona, L-U-N-T. And this is a 80 millimeter hydrogen alpha telescope, and it can only look at one thing. So it's only good for seeing the sun. But if you go to my Instagram, AZ Astro Guy, you'll see a number of photographs that I put there of the sun, and you can see solar flares, and you can see sunspots and surface detail and filaments and all sorts of detail there. So you can get some really great pictures of the sun with that telescope, but that's all it does. So in fact, every morning I've got a routine. I take a look at the Solar Dynamics Observatory website to see what the sun looks like right now, because they have a satellite that's watching the sun 24 hours a day in hydrogen alpha. And I can have a quick look at the SDO website and see whether there's an interesting solar flare at the moment. Because the sun is a very dynamic object. It's the one thing you look at in a telescope that is very different from 1 hour to the next. If you look at the moon, it's pretty much the same every time you see it. If you look at Saturn or Mars, they rotate, but it's the same object. If you look at galaxies and star clusters, maybe there's a supernova that goes off once in a long while, but otherwise they look pretty much the same. But the sun is a very dynamic object, and so it's interesting to see. So I'll take a look at the website and see, hey, is there something interesting today that might be worth taking a picture of? And then if there is, I'll take a photograph of it and post it on the website. So I have a Lunt telescope for solar viewing. And then I have 2 refractors. I've been through a lot of different types of telescopes over the years. And I personally tend to prefer a refractor. I like the quality of the image you get. I've got a apochromats, so they're high quality triplet instruments. You very, very razor sharp images of the stars. I have had some Schmidt-Cassegrain designs, for example, which are a great blend of portability and cost and aperture. They're really terrific, and that you can get a lot of aperture for a reasonable price and be able to carry it around. But I never found I was as happy with the image quality as I was with a refractor. I could never get that perfect little stellar dot. So, but I certainly have seen people who have great results with those telescopes as well. And in fact, I'm thinking about buying a 925 next month, perhaps. But anyway, I've got a TEC Tech 140 ED. That's an apochromat, 140 millimeter apochromat, and I also have a Skywatcher Esprit 100 ED apochromat. So what I do is I can put a 0.65 focal reducer on my Esprit, and I can get a very, very wide field of view. So that's great for looking at very large objects like the California Nebula or the Seagull Nebula or the Heart and Soul Nebulas, things like that are very, very big, much bigger than the full moon. And then the Tech is an F7. It's very versatile. I can look at galaxies and see detail. I can look at moderately sized objects up to the size of the full moon and get that all in at once. So it's a very versatile telescope for looking at a lot of different types of objects.
Got it. Okay, so I love the fact that you mentioned again about Lunt, telescopes, because that's something that not a lot of people bring on a podcast when I talk with them. So again, anybody who want to kind of take some images of the sun, of course, you should go and search of these Lunt solar telescopes. And the website that you mentioned is called SDO. If you just Google that, you're going to find it's a NASA's official website of current, showing basically where the sun is now. So that was very awesome.
Well, it's cool. If I can interject there with SDO, you'll see that it actually shows the sun in different wavelengths. So you'll see the sun in hydrogen alpha, you'll see it in visible broadband light, you'll see it in calcium wavelength, and there's different surface features visible at different wavelengths, which is really interesting.
It is, yeah, because I'm just looking at it right now. So yeah, that's pretty cool that it's official and it's all this information there. And again, when we're talking about, again, apochromatic equipment that you mentioned, it could be a little bit pricey for the people, when it comes to buying the equipment.
Yes.
But look, as I mentioned, you can start again. You gave a great advice by saying you can buy secondhand, from somebody who kind of, thought they're going to
Mhm.
pursue this and they just abandon it in the garage. And you can find those deals again, mentioned Cloudy Nights or maybe some other websites,
Yeah.
available on in their countries. So talking about the sun, sun could be a little bit of a problem, not sun, just the light itself, because, we live in the cities right now. We're stuck in these places where there's a very high
Yes.
light polluted areas. So for the people who are looking to begin astrophotography, what's the way for them to tackle, and what type of maybe filters they can use to tackle that problem?
For you talking about for the sun or for the night sky?
No, sorry, for the light itself, for the light pollution.
Oh, for light pollution.
Yeah.
Okay, so yeah, so the issue you have is that when you're looking at things from the city, you're dealing with, as you say, a lot of background light pollution, and that tends to make the stars faint, and you can't see the level of detail. It also makes it difficult to find things in the sky. So when I was a kid, the way you found things, you what's called star hopping, and so you'd say, oh, I see the bright star, and now I know there's a fainter one to the left. You look at your star chart, you look back at the sky, and you can use binoculars, and it took a long time. But if you were in a reasonably dark location, you could find something like a globular cluster or something or a galaxy that wasn't necessarily near a bright object, and you can kind of hop your way to it. But now what people are using are go-tos systems and mounts. So if you can afford that, you can get them for a few $100s now. It really saves you a tremendous amount of time just to line on a couple of bright stars, and then it would just go to whatever object you want to see. So assuming you can find the object, then the advantage of filters is that they allow you to block out some of the broadband light from the street lights and from house lights and things like that. So you can get this kind of, when you look at the night sky, I'll just generalize here, but there's two broad classes of filters. There's a broadband filter, which kind of knocks out the light pollution. And then there's a narrowband filter that notches out all the light except for the specific wavelength of the thing you're looking at. So an example would be, let's say you want to have a look at the Ring Nebula, which is a fairly bright object in the constellation of Lyra, a little planetary nebula. It looks like a little smoke ring. You could try looking at that, and that's actually really relatively easy to find because right between two bright stars at the end of the constellation in the middle. So that one you can kind of find easily. But you can use a broadband filter to kind of knock out the light pollution, and you'll see better contrast with the object. Or you could use a narrowband filter if you know the object is emitting a lot of light in what's called hydrogen alpha, for example, or oxygen 3. And you can look up what wavelengths different nebulas tend to emit. The most common one is hydrogen alpha, and you can buy filters that allow, say, O3 and hydrogen alpha to come through, and you can see them, and that allows nebula. They call them nebula filters. They allow those wavelengths to come through and block out the city lights, and that gives you much better contrast and kind of makes the image pop so you can see it.
Got it. So part of that is, again, the buying the equipment, getting the mount, the scope, and buying the filters and knowing how to tackle all these problems. Like one of the biggest, I wouldn't say problem, but it's a challenge, when it comes to the stacking images and post-processing. So can you talk about that? What type of softwares do you use for those things as well?
Well, again, I'll preface it by saying I'm a little bit of a beginner on astrophotography. I really haven't gotten serious about it until June of this year. So I've been only doing it for a few months, although I'm getting some pretty good results already.
Yeah.
So the software that was recommended to me and that I've kind of embraced for planetary imaging is called SharpCap, and it's made by a guy in the UK, and it's free, which is a great price. Now I'm using the Pro version, which costs a whopping £10 per year to use, which I think is a very good investment. And that gives you some additional features like live stacking. What that does is it looks at the object and it captures, you can specify how much time you want the exposure to be from milliseconds all the way up to minutes. And then it will take that exposure and then it will take the next one and stack it on top of the first one. You build up more and more detail over time. And so typically, the photographs that I put on my website, I really don't have anything there that I've taken more than 5 minutes with. I mean, you look at people who, and I applaud them. I saw one recently, somebody showed a nebula in Cassiopeia that he had imaged for 52 hours. And I thought, good grief, that's a tremendous amount of effort. I really respect him for doing that. We had, 27 hours in this wavelength and 31 hours in that wavelength and 10 hours in this wavelength. and stack them all together. I mean, I don't have the patience for that. I mean, I respect people who can do it, but it's not for me. So I like to get, 80% of the quality of that kind of a picture in 5 minutes. That's kind of the way I like to look at it. So, and that's what you can do with these new cameras. So SharpCap is great because SharpCap allows you to process the image, stack the image. You can save it as a PNG or as a raw file. You can capture video. So I should say there's a difference between looking at deep sky objects and planets, for example. So a deep sky object, typically you'd capture the light, you'd stack it, and you look at the image. With a planet, what you tend to do is you run a video camera, and you run the video camera for, let's say, 2 minutes. And maybe if you're running at 100 frames per second, you may capture 40,000 frames. And then the next thing you do is have a different piece of software called Auto Stacker, and that's free as well. What that will do is that will separate all the individual frames from the video and then figure out which of the frames are the most in focus. Because when you're looking in the sky, as you know, there's turbulence in the sky and there's variation in image quality and things come in and out of sharp focus. And so the software can take a look and say which of these frames during the time we looked were the best frames, and then stack those together. So maybe you say, just give me the best 10% of the frames that we captured out of all the frames. And then that will give you another image. And then from that new image, you can then go to a third piece of software called Registax. And Registax will then sharpen the image. And then you use those little sliders. Registax is also free. And you can use little sliders to sharpen the image to the extent that you want. And then once you're all done with that, you're probably good to go. Or you might choose to do a little final tweaking in Photoshop Elements or GIMP or one of those types of packages. But that's not strictly necessary at the end. So planets are more work, if you will, than other things. If you're a beginner, and now if you want to take an object like M31, the Andromeda Galaxy, and you want to tease out a lot of detail in the dust lanes and little knots of stars inside the galaxy, then you're going to take a lot more time with something like Photoshop and get really detailed into layers and curves and go beyond kind of what we can do in the podcast today. But if you are interested in that, again, there are plenty of resources on YouTube. You can just search for some of those types of files, like how do I process M31 in Photoshop, and you'll find tutorials on that for free.
Yeah, exactly. I mean, it's tutorials on tutorials. There is a tutorial on how to find a tutorial on the tutorial. It's like, it's crazy. So yeah, it's so much information available. And again, I love the fact that there's all of these, majority of the softwares are kind of free, or maybe £10, like let's say euros or dollars per year, which is almost which is almost like nothing, free, but the time is priceless. How much time you're going to spend, learning and, crafting your, your best ever pictures and photos that you can post later on Instagram, let's say. So, and part of that, again, I love the fact, again, of the photos that you put out, because I didn't know that you've been involved for just a short period of time, but, because when you look at the images, I mean, they're really cool. I love the one that I looked at. It says Happy Halloween, and that was posted October 31st. I love that one. Those series.
Yeah.
So some great imaging, some really great imaging. So make sure to go and follow as Astro Guy again on Instagram. And part of that, I know that you're involved in some projects. On some of the projects involved, I mean, you're a NASA Solar System Ambassador. So can you talk about that? I mean, what does it take for you? I mean, what's your kind of main objectives and one of the main things that you do with that position?
The main objective there is educational outreach. So ambassador essentially means ambassador for NASA, helping to explain what's happening with space science, why it's important for us to go to space and explore the cosmos, and what's happening with new missions, and what's happening in space. What does it mean when someone says there's a meteor shower, or simple things maybe to you and I, but the layman may not understand what an eclipse means, or someone says Mars is at opposition. What does that mean? I do a lot of public outreach events, as I mentioned earlier, with my telescope. I also give talks at libraries. I'll go and I'll give talks on the search for intelligent life in the universe, or mysteries of astronomy, or different topics I've got. I do the same thing, well, not now right now, but prior to COVID, I was giving talks on cruise ships. In fact, I did one in Princess cruise ship in February of this year. Just as COVID was starting, I was on a cruise ship, in Southeast Asia, in Vietnam and Cambodia and places like that, giving talks on astronomy, and just sort of got home barely before things went crazy. So that was a close call. But I do that several times a year, usually cruise ship talks, and just every opportunity I can. I write a lot of articles. There's the website called astronomhub.com, and I've written a lot of articles for them on different astronomy topics. So wherever I can, I try to communicate and educate on astronomy, space science.
Got it. And I mean, probably that's one of the recipes for you being involved with the astronomy for 50 years. I mean, what's not to enjoy? I mean, you get the free cruises, you get to meet a lot of great people, you talk about space and why people should get involved. I mean, it's fascinating, so that is awesome. So again, because you mentioned, a lot of great topics that we can probably talk about for hours and hours and make a separate podcast episodes on that. But when you meet brand new people that, again, never never came across the information that you talked about before, how do you talk with them, and what did you tell those people, and why they should go and pursue space exploration related to type of information, resources, and the topics?
So, well, it really depends on, I guess one of the questions you get sometimes is, why should we spend money on going to space? We have so many problems at home. We've got people who are in poverty, and we've got problems with climate change, and the list goes on forever of things you could spend money on if you wanted to, right? So why should you spend money on space? Well, first of all, we're not spending a lot. I'm talking about the U.S. now as an example. We're not spending a lot, relatively speaking. About 1% of the U.S. budget goes to NASA, so it's a very small amount compared to social programs and other things. But you look at the reasons for exploring space. I mean, you want to improve our knowledge of science, to understand cosmos, the origins of matter and energy. There's kind of a national prestige element. Great nations undertake great things. There's a national security aspect. I mean, you want to maintain the high ground. If you don't go into space, then your adversaries are going to go into space and have advantages over you. There's an economics aspect. I mean, the technology that we use today in our smartphones includes some rare elements like tantalum, for example, and iridium, and things that you don't hear about, like iron and nickel all the time, but the things that are rare elements, but they're vital to the operation of our smart electronics and our whole society now, which is based on the internet. And so if we run out of these elements, and we are running out of these elements, we're going to be stopped dead in our technology tracks. And if you take a look at some of the asteroids that are out there, like for example, 16 Psyche is worth over $1,000 quadrillion. Okay, and that's a number that's too big for people to understand. But what that means is the metals in that asteroid, if you could bring that asteroid home, that would have a value equivalent to $1.5 billion per person for every person on Earth. That's how much metal and valuable elements there are in there. So eventually we're going to be forced to go outside the Earth and look to the moon and look to asteroids, other places, to get some of the necessary elements we need to maintain our civilization. That's just a fact, because we are running out of some of these rare earth type elements. So there's that. We learn more about sustainability by looking back on the Earth from space. We can learn about climate patterns, and so understanding what's happening on the Earth. It's important to be in space to do that. By looking at the planet Venus, for example, we understand more about the runaway greenhouse effect, which could affect the Earth with climate change. That's helpful as well. We also want to inspire, and we want to educate and create the next generation of scientists and engineers out there. And so education and inspiration, kind of part of what I do, it's good for that. And finally, the reason that you and I are not talking to each other as dinosaurs is because the dinosaurs didn't have a space program. And when the asteroid hit 66 million years ago, they were all wiped out. And it is inevitable that there will be another event like that another large asteroid will hit the Earth and cause a cataclysm. Or maybe we have super volcanoes go off, or maybe there's a gamma ray burst, but something is going to happen which is going to cause a lot of problems for life on Earth. And we need to be a multi-planet species at some point if we want to avoid the fate of the dinosaurs. So those are some reasons why it's important to go to space.
Got it. I mean, there's more reasons behind that as well. So again, talking about the meteorites and extinction, it's not going to happen in 2020. Just please clear this out, because we already have enough problems.
Yeah, there is an asteroid that is going to get very close past in the year 2068. Okay, and that's the one that they're most taking a close look at right now. So probably not going to be anything I'm worried about in my lifetime, but certainly we want to understand that. In fact, NASA's sending missions out to look at how they can deflect asteroids, and the further away you can see them in space, the better chance you have. It takes a smaller nudge to move it away from Earth's orbit when it's a long way away. When it gets very, very close and it's no time left, that's when it's more urgent. But yeah, there's nothing that's happening in the short term for sure, but it is going to happen eventually in the long term. And so we want to not be having all of our eggs in one basket and one planet if we can avoid it.
And we cannot be dependent just on Jupiter's gravity anymore. I mean, we need technology as well, right? to deflect the asteroid. So okay, so yeah. I mean, what else do you see kind of being insider, 50 years plus and counting, again, being involved with solar system, being a solar system ambassador and talking to the cruise ships and with people. So it's really cool. I mean, I love what you do. So again, what do you see when it comes to upcoming technology and like maybe not in technology, let's say in a machine learning or kind of AI based technologies that will kind of disrupt the future, let's say industries across the different boards, astrophysics, space engineering, and make it better for the future?
Well, it's a really open-ended question. It's hard to answer that one. There's just so much things that can happen. I was playing this morning before the podcast with some software by a company called Topaz. That's a denoise software, and it uses artificial intelligence. And this is software less than $100 that anybody can buy. You get a free trial. I just tried my free trial. And I was looking at some of those photographs that I published on my website, and I went and put them through the software, and all of a sudden you can see much sharper stars and better clarity in the nebula. And I thought, wow, this is great. So I'll probably end up buying the software to try to improve my imaging. But there's an example where artificial intelligence is being used to take the noise out of astronomical images and improve the quality of the picture that you get. There's some technology now called adaptive optics. Right now is only being used at observatories, where they basically send a light into space, they create an artificial star, and then they have a deformable mirror that literally changes its shape over 1,000 times per second. And what that does is it counteracts the effect of turbulence in the atmosphere and effectively makes a ground-based observatory have the same kind of reach into space as a space-based telescope like the Hubble. And that technology is slowly moving to amateur astronomy. So I can see in maybe another 10 years, you'll be able to buy a reflector telescope that actually has adaptive optics in it, which can help to eliminate the effect of turbulence in the atmosphere, which would be a fantastic benefit for amateurs.
Well, it definitely would. I mean, so yeah, we're talking some crazy stuff coming up in the near future. And again, you mentioned, it's the second time somebody mentions topazlabs.com. That's the website and that's the software that you're using. Yeah, it's basically AI.
I just tried it. Yeah, the denoise software. It actually worked very well in the test images I looked at. So, and they have a nice free, it's a fully functional version for 30 days. I'm not associated with the company in any way, but if you do have any kind of astrophotographs and you want to see whether it might make your pictures look better, that's something you could try, experiment with. Got
it. So from the technology perspective, I mean, do you see something else coming up, because one of the biggest problems that I think, space agencies like NASA or, ESA, ASRO, and the private companies just like Elon Musk or, everybody else, is to work on jet propulsion systems. And again, the talk is going around, it's going to be kind of nuclear powered jet propulsion, system. Besides that, is there anything kind of excited coming up in the near future that people should be paying attention to?
Well, the Dawn spacecraft used an ion drive, and that's a spacecraft that actually went to Ceres and looked at Ceres and some other things in the asteroid belt. And that's a propulsion system which uses very, very little energy, and it's very lightweight. The problem we have with traditional rocket engines, of course, is that you have to lift the whole mass of fuel up in the air. So, having some kind of a more efficient system is what we really need. Unfortunately, the ion system doesn't have a lot of energy propulsion. It's a slow system. It's good for long, slow missions. It's not good for getting to Mars in a hurry, for example. So, nuclear systems, I think, would be interesting. We're still a little ways away from getting those where they're, understood and safe. But I think that's something the problem will be solved. It's really an engineering problem at this point. It's not really a physics problem. There has been, if you want to be more speculative, some interesting work done on warp drive. So people think of Star Trek and and fantasies like that, which we all enjoyed if we're interested in space science. But there's a guy called Dr. Alcubierre, a Mexican astrophysicist back in the 90s, who actually wrote the equations for warp drive, and I'm talking real warp drive. And he figured out how to do warp drive, which was consistent with Einstein's equation. So we're not trying to break any rules. And basically creates a space bubble. You can look it up, Alcubierre warp drive on the internet. And NASA actually designed a spaceship, and there's a YouTube video, you can look at it, that was what would look like if you used a type of warp system. And the physics is actually very well understood. There is a minor problem, and that it requires about as much energy as the so we don't have the technology to create an energy source big enough to power the warp drive. But I'm excited about the fact that they've actually developed physics that can support going faster than light. And when they first designed this concept, it required the energy of the entire universe to operate. And now I've gone from the universe down to the galaxy, down to the sun. Still far more energy than we can create right now, but we're going in the right direction. So there may be some young person listening to the podcast today who comes up with the science that allows us to solve that problem, and we may find ourselves in Tau Ceti and Zeta Reticuli before long.
Here you go.
That would be exciting.
Here you go, Zeta Reticuli. I love that. Love that. Yeah. So here you go. So talking about some stars, you're mentioning that you're currently looking at the binary star systems. So can you expand on that? Why are you paying attention to that at the moment?
So yeah, so I've always been interested in double star binary star systems. It's just, to me, it's fascinating that you can have two stars that circle each other around a common center of gravity. I mean, we're so used to our star being a single star, but it turns out that half the stars you see in the night sky are actually binary or trinary or more. In fact, one of the really interesting stars, people sometimes ask me, what's your favorite star? And aside from the sun, my favorite star would be Castor. And Castor is one of the two bright stars in Gemini. So if you wait until very late tonight and you look up in the east, you'll see Gemini rising in the east. The two bright stars are the twins. One's Pollux and one's Castor. So Castor happens to be a 6-star system. So if you look at Castor in a small telescope, you'll see two stars, two bright stars. If you look at it in a little bigger telescope, like on my telescope, you'll see two bright stars and then a little red star off to the side. And so what you have is you have the two bright stars circling each other, and then the red star is a red dwarf circling the pair in the middle, a triple system. But then if you have a really big telescope with a spectroscope, you actually see that there are two pairs of spectral lines for each of those stars, which means that each of those stars is itself a binary star. And so in the center of the system, you have a tight binary circling it, mutual center of gravity. And then beside that, another tight binary. Those two binaries circle each other. So 4 stars there. And then way out in the distance, there's a double red dwarf circling itself, which then circles the 4 in the middle. So it's a 6-star system, which to me, it's astounding. You can have a stable 6-star system. Imagine you are on a planet in that system, circling one of the stars. You would see 6 suns in your sky, not one like we have. I mean, to me, that's just, it's amazing. So I've always been interested in binary systems. I think they're fascinating. And, there are some really common ones like Albireo, which is it's also called Beta Cygni. It's right overhead tonight. Even in a small telescope, it's very easy to split, and it's a colorful star. You've got a yellow star and a blue star. So the blue star being hotter and the yellow star being cooler. A lot of beautiful double stars that are colorful you can look at in a small telescope. That's always been a lot of fun for me as a younger astronomer. But more recently, one of the challenges you have is as stars get closer together, obviously it gets more difficult to split them. So the answer usually is go to bigger aperture. The bigger the mirror you have, the bigger the lens, easier it is to split stars that are closer together. The other problem you have is unequal magnitudes. So a good example would be if you look at Rigel. Rigel is the right foot of Orion, a bright winter constellation star. And even a small telescope can split Orion, or even Polaris is a good example. Everybody can see Polaris in the Northern Hemisphere. It's a bright star with a faint companion. So you can see the unequal magnitudes of the two stars, but they're far enough apart you can split them with a small telescope. But what if you have different distances between the primary and the secondary in different magnitudes. So there's a astronomer called Sissy Haas, Haas, and she's doing a research project that I'm contributing to, where astronomers all over the world are looking at a long list of unequally magnitude double stars, and we're trying to see what aperture does it take to split a given pair, given maybe one of them is, let's say, 4.5 magnitude for one star and then 8 magnitude for the second star, and they're 2 arc seconds apart versus 4 arc seconds apart. So you combine all this data from all these observations and all these telescopes, and we hope to develop basically an equation that will tell you what aperture do you need to split unequally brightness stars of different spacings. So kind of an esoteric thing, but I'm hoping to contribute to that effort.
Beautiful, beautiful. And that's happening because of the collaborations, you know, so just
yes,
like you mentioned,
all around the world, people are working on that together.
Exactly, exactly. So I love that. So again, part of that, again, can you talk about telematrix.com, the website? And again, there is a section calling about astronomy outreach, and maybe you can talk about some future upcoming events and the projects that you're going to be working with.
Yeah, thank you. So so I have a consulting business which is separate from my astronomy called Telemetrics. I do high technology consulting, strategic planning, and M&A and wireless and stuff like that. So that's my kind of my day job, if you will. And then what I do, that business kind of funds a lot of the public outreach that I do. Helps me buy equipment, helps me do public outreach, see travel places to give events for people. And so I've got a page on my website dedicated to my astronomy outreach stuff, which is what you referred to there. And you can see it in the show notes, I'm sure. Mm-hmm. So, locally, the challenge we have now, of course, with COVID is it's harder to do face-to-face events. I had a lot of, library talks and school talks and things like that, which have all been canceled until things change. I had cruise ship trips planned. Those are canceled until things change. What I have been doing recently is there's a new type of kind of live outreach called the EAA, stands for Electronically Assisted Astronomy. And what I do is I take my telescope with the digital camera, I attach it to a PC, and then from there I go by an HDMI cable to a large monitor, TV monitor, 32-inch monitor. And then people can come and sit in little clusters, their own little COVID cells, if you will, family cells, and they can sit apart from each other, but little people together, sitting on a blanket or in folding chairs in a kind of a semicircle in front of me, and have maybe up to 30 people look at the monitor, and they can see that without having to approach me or the telescope or each other, and stay kind of in a safe little zone by themselves. And that allows them to then look at the object. So I will look at the Andromeda galaxy, and I'll show that on the big screen and point out the dust lanes and talk about the companion galaxies and other things, and answer questions, and then move on to a nebula and show, for example, M27 planetary nebula, or the Ring Nebula, or the Pelican Nebula or something, and then answer questions about that, go to a star cluster. And so I'm doing public events like that. And locally here in Scottsdale, Arizona, the next one of those is December 12th at Pinnacle Peak Park. So I'm doing local events for the short term. And I'm still trying to write lots of articles and things like that too, and publish photographs. And whenever I publish a photograph on my Instagram, I try to have a little bit of explanation about what it is and how far away it is and the nature of the object. So a little bit of education as well as a pretty picture. Yeah.
Yeah, so the posts are great, and that's how we met, and that's how we get connected through Instagram. So make sure to go and follow Mark as Astro Guy on Instagram. Of course, you're going to find that, and for the website and upcoming events, as he mentioned, for the astronomy outreach section, or just to go through and take a look at the Telemetrics website itself. That's telemetrics.com. So again, a lot of great information. I mean, so a lot of great topics we covered today, but which of course we missed so many because there's so much more to cover. But again, through your personal 50 years plus career, and like doing all these things involved with the projects and speaking and impacting people, like, is that what your legacy wants to be like, or maybe there's something else that you want to add to that as well?
I just enjoy sharing my passion for astronomy with the public. And there's a lot of simple things you can do even without a telescope. So for example, there's a website called heavens-above.com. So a little hyphen between heavens and above. And you simply enter your location on the earth, wherever you live. You use a map, or you have GPS coordinates, however you want to do it. And then it will tell you all the satellites going overhead that night. And so what's particularly fun is the International Space Station is very, very bright and very easy to spot. Even if you're in the middle of London or middle of New York City, you can't miss the ISS. It's so bright. It's much brighter than any planet, for example. And so you can go to the website and it will tell you exactly when and where the ISS will appear where you live. And so you can say, oh, tomorrow night at 6:30 p.m., starting in the Northeast, it's going to rise in this constellation and go across the sky in this direction, and then 4 minutes later fade away in that constellation. And so you can walk outside and you can have your look at your watch and you can say, okay, in 3, 2, 1, and it appears right where you expect. It's a lot of fun. It's fun to do with people. Bring people out and they can see the space station where we can wave at the astronauts. So I often do that. That's something you can do for free with no equipment whatsoever, and you can do it no matter how city light pollution you've got. It won't matter what go on. There also are a number of different projects. You can go to NASA and look at the public section. There are things you can do to help measure light pollution, for example. They ask you to go and look at a particular constellation and just simply report what stars can you see. And because they'll give you a map showing all the stars, and you say, okay, I can see these 3, but not those 4. And you just report that on the internet, and that helps them understand what the light pollution is in your area. And people can contribute to light pollution research all around the world for free doing that as well. There's a lot of citizen science that people can do that costs them nothing. I think NASA's got 22 different programs you can do with citizen science that are free. So that light pollution one is actually called Globe at Night. That's the name of that program. So a lot you can do for free without equipment whatsoever. And even before you buy equipment, what I've found is people who are into the hobby like I am and the passion are more than happy to share their knowledge and expertise and show you their equipment, bore you to death almost with their interest in the topic. So you can get someone to show you what they're doing and give you an example of what telescopes look like and so on, and how they're used without having to spend any money whatsoever. And then if you do find that you really are interested and it's something you want to pursue, then you can get in through low cost methods like renting observatory time, as you mentioned earlier, or buying used equipment, or even borrowing equipment from clubs. A lot of clubs have an extra telescope that's available to be borrowed.
Okay, got it. So look, that's my intention, basically to bring people just like Mark on the podcast. And I know those people don't bore you. Those people inspire you to go and pursue your own personal journey when it comes to space exploration.
Yeah. It's fun.
And look, there's so much more available. Like, I had not long ago, a guest on my show. He talked about basically creating a hospital on the moon, and they did a project, which again was part of the, I can't remember right now, the organization. Oh, there was an Aldrin Foundation, basically, that organizes.
Oh, yeah.
Yeah. So they organize basically that project for people, anybody who want to get involved with that and kind of try to, to simulate, and go through the problem solving issues and stuff like that, how to create this moon-based hospital, which is really interesting. So again, cool. There's a lot of different options available for everybody to join and become part of this kind of big mission and big vision. So I do recommend for everybody who are watching or listening, get in contact with Mark himself personally, and make sure to ask questions about maybe that's about, astrophotography equipment, or maybe something else.
Sure.
This man is definitely available, and so I'm so grateful to have you on today. So a lot of people can get inspired, get the inspiration, strategies and tips. I mean, there's so much more. 50 years plus. So that's amazing. That's amazing. So again,
yeah, that's fun. I enjoy it.
Thank you. So guys and girls, one thing that I wanted to ask you before we're going to go, if you shared this episode with a friend of yours, and of course, any friend that you want to, because as I said, we need more people to get involved as possibly can with everything that's happening right now, because I have a feeling that we're on an edge on something great coming up in the near future. So make sure to pass this episode along to your friends. Mark, for you personally, big thank you again for coming over today and sharing your personal journey, passion, and all the tips and strategies. I really appreciate it.
I enjoyed it. It was a lot of fun. Thank you so much for having me on.
Thank you. So guys, make sure to pass this episode along. And as always, I'll see you next time. And don't forget, keep exploring.